Hello, good evening, madam. Uh, Please make me a host, madam. Hello, madam. Yeah. Good evening, students. Let us take up the another a small chapter of second PU, that is electromagnetic waves. Now, in the previous chapters, you have studied about the concept of the electric field, which is nothing but the space or a region around the charge where its influence can be felt. And also you have studied about the concept of the magnetic field. Which is denoted by the symbol B. Magnetic field is the one which is going to constitute when the charge is in motion. That means when the charge is in motion, it constitutes a current. Because of the current, it induces a magnetic field. Now, in this electromagnetic waves, we are going to club this both electric and magnetic field. We are clubbing electric field and magnetic field. After clubbing these two, whatever the disturbance is going to set up in a medium, that disturbance is what we called as the electromagnetic waves. And mainly these electromagnetic waves, in order to set up this electromagnetic waves, you have to accelerate the charges. So by accelerating the charges, you can create the electromagnetic waves. So to create the electromagnetic waves, the charge should get accelerated. For example, if I am applying the electric field along the y-axis and there is a charged particle here, this charged particle is accelerating along x-axis with the velocity v. Perpendicular to this electric field, I am going to apply the magnetic field. Here, electric field and magnetic field are perpendicular to this velocity. Because of that reason, these electromagnetic waves are considered as the transverse wave. So electromagnetic waves are transverse in nature. So in order to create the electromagnetic waves, you have to apply the both electric and magnetic field. Whenever you are going to apply the electric and magnetic field, the charged particles is going to get accelerate and it creates its own wave. This wave is what we called as the electromagnetic wave. This is what we considered as the electromagnetic wave. Clear? So in order to produce the electromagnetic waves, we require the two fields, that is electric field and the magnetic field, which are applied perpendicular to each other. Whenever this charge is moving perpendicular to both electric and magnetic field, the particles will move perpendicular to it. It will accelerate. That is what we considered as the electromagnetic waves. So whatever the equation we are analyzing now, the electric field which is applied along the y-axis is given by the formula E naught, which is called the peak electric field, the maximum electric field, into sine kx minus omega t. And there is a magnetic field which is applied along the z-axis, that is given by B naught into sine into k. Now magnetic field is applied along the z-axis, so I'm using z-axis. But still the particle is moving along x-axis, so kx minus omega t. So E naught is the electric field, which is the maximum electric field, which is called peak value. B naught is the magnetic field, which is called the maximum one, that is called peak magnetic field. Clear? So these are the two equations of the electromagnetic wave, that is electric field and the magnetic field. You know that K is a propagation constant. That propagation constant is given by the formula K is equal to 2 pi by lambda, and omega is called the angular frequency, that is 2 pi f. And whenever these electromagnetic waves are moving, it moves with speed of light. Electromagnetic waves moves with speed of light. The speed of light is moving with the value c. That c is given by the formula E naught divided by B naught. So please remember, what is the electric magnetic field speed anta andre? The speed of the electromagnetic wave is moving with the speed of light, that is 3 into 10 power 8 meter per second. But remember that speed c is equal to E naught divided by B naught. E naught is the peak electric field, B naught is the peak magnetic field, or you can say maximum electric field, and B naught is the maximum magnetic field. Clear? And mainly this electromagnetic waves was explained by the scientist called by the name Maxwell. Suppose if this is not taking place in an air medium, instead of air medium, if it is taking place in other than air medium, then the velocity is given by the formula just E divided by B, which you are familiar with the previous chapter, that is magnetic field and the magnetism. So what is the speed of the electromagnetic wave? It is given by either V is equal to E by B, or you can tell C is equal to E naught divided by the B naught. And also the Maxwell has corrected the Ampere's circuital law. He has corrected the Ampere's circuital law. So who contributed the correction in the Ampere circuital law? That is called the Maxwell's. Now, according to Ampere circuital law, you know that the line integral of magnetic field, that is B dot dl, must be equal to what? Mu naught times the total current, which you considered as the conduction current. This is Ampere circuital law. But this law is not going to be the universal law. If I apply the same Ampere circuital law for the capacitor, there you cannot prove this between the two plates of the capacitor. If I consider the two plates of the capacitor here, this Ampere circuital law fails between the two plates of the capacitor. So in order to correct that, between these two plates, the electric field keeps on changing. This electric field keeps on changing. Whatever the time varying electric field is there between these two plates, that time varying electric field between the two plates is going to create another current. That current is what we called as the displacement current. So what is displacement current? Displacement current is the one which is going to constitute because of the changing electric field. Because of the changing electric field, whatever the current is going to constitute, that current we call it as a displacement current. Please remember that displacement current is denoted by the symbol ID. and that displacement current ID is given by the formula epsilon naught into d phi E divided by dt. Epsilon naught into d phi E divided by dt. Epsilon naught is a constant called absolute permeability. D phi E by dt is called the rate of change of electric flux. D phi E by dt is nothing but the rate of change of electric flux. So, according to the Ampere's circuital law, the Maxwell's equation is going to be rewritten. So, integral of magnetic field, that is B dot dl, is equal to mu naught times of conduction current plus one more current that is due to the varying electric field, that is called the displacement current, that is ID. So this is the modified form of the Ampere's circuital law. Got it? Yeah. Now let us take up the properties of this electromagnetic waves. The properties of electromagnetic waves. So in this, properties of electromagnetic waves. What are the properties of electromagnetic waves? The first one, you know that the electromagnetic waves are going to travel with the speed of light. Electromagnetic waves travels with the speed of light. That speed of light is given by the formula C is equal to, you know that it is given by E naught divided by B naught, which is also given by 1 divided by root epsilon naught into mu naught. So speed of light is given by the formula C is equal to E naught by B naught, or you can write it as 1 divided by root epsilon naught into mu naught. And the speed of the electromagnetic wave in the other than air medium, if it is not in the vacuum medium, other than air medium, its speed is given by the formula E divided by B, or which can also be taken as 1 divided by root epsilon into mu, where epsilon and mu are the absolute permeability and absolute permeability of the given medium. So please remember the speed of light of the electromagnetic wave. What's the formula for the speed of electromagnetic wave? C equals to E naught by B naught, or 1 divided by root epsilon naught mu naught, or in terms of other than air medium, V is equal to E by B, or which can also be taken as 1 divided by root epsilon into mu. Now, let us take up the second important property, that is energy. Now, let us talk about the energy of the electromagnetic wave. The energy of the electromagnetic wave due to electric field. The energy is given by half times of epsilon naught into E squared. Half times of epsilon naught into E squared, which is called the energy density. I'm talking about energy per unit volume. That is nothing but energy density. And what is the energy density due to magnetic field? It is given by the formula of times of B squared divided by mu naught. So what is the average energy density for electric field? Of times of epsilon naught A squared. For magnetic energy, of times of B squared by mu naught. Of times of epsilon naught into E squared, and of times of B squared divided by mu naught. Therefore, you can find what is the total energy of the electromagnetic wave, that is of times of epsilon naught into E squared plus of times of B squared divided by mu naught. So that is the total energy in the case of electromagnetic waves. So let me take up the third important property, that is intensity. The third important property is intensity. Now, in the case of the intensity, please remember, intensity of the electromagnetic wave is defined as the total electromagnetic energy. Total electromagnetic energy to the surface area into time. Surface area into time. So total electromagnetic energy divided by surface area into time is what we called as the intensity. Please remember that intensity is nothing but the average energy either in the electric field or in the magnetic field into C. Into C, this is called as the intensity, which is going to be measured in terms of watt per meter squared. You know to write the average energy density. In the case of electric field, it is half times of epsilon naught T squared. If it is magnetic field, then half times of B squared by mu naught. Now, coming to the next important property, that is momentum. Momentum. What is the electric intensity of the electromagnetic wave momentum? The electromagnetic wave momentum is given by the formula U divided by C. U divided by C if it is a absorbing surface. If the surface is an absorbing surface, then the momentum is given by the formula U divided by C. Suppose if it is a reflecting surface, if it is not absorbing, if it is reflecting, then the total momentum will be 2 times of U divided by C. If the surface is reflecting, then the momentum is 2 times of U divided by C. And if the surface is absorbing, then the momentum is given by the formula U divided by C, where U is the energy and C is the speed of light. So these are the 4 important property you must know in the case of electromagnetic wave. That is speed of light, energy per unit volume. The third one is intensity. The fourth one is the momentum. So you know the concept of the electromagnetic spectrum. You know that all the radiation of the electromagnetic waves are arranged in a proper ordered sequence. That is what we called as the electromagnetic spectrum. What is that order arrangement of the electromagnetic waves? You know that it is arranged in the proper sequence, either in the increasing order of wavelength or in the decreasing order of wavelength. So the very highest wavelength is radio waves. Radio waves is having highest wavelength than microwaves. Please remember this order: radio waves, microwaves, then infrared, then visible, then UV rays, then X-rays, then please remember the gamma rays. So this is the decreasing order of wavelength, or you can say in the increasing order of frequency. So for which spectrum the wavelength is more? The wavelength is more for the radio waves. The wavelength is more for radio waves. The wavelength is very less for gamma rays. Remember that. And also you have to remember the wavelength ranges of this electromagnetic spectrum and also the uses of this electromagnetic spectrum. So you know that the radio waves are mainly used in communication purposes. Microwaves are used in the case of microwave ovens. Infrared are going to be used in eye surgery. visible to see the object around us. UV rays are mainly used for the water purifier cases. X-ray mainly it is used to study crystal structure, and also you can see the medical field applications to find the fractures in the bones. And also gamma ray mainly used in radioactive phenomena. In the case also of gamma ray microscopes, we are using the gamma rays. So these are the applications, general applications you have to remember in the case of electromagnetic spectrum. Got it? So these are the concepts in the case of electromagnetic spectrum. If you have any doubt related to this, you can ask, or we can take up the questions based on this electromagnetic waves. It's a very small chapter, students. But you can expect one question. Okay, I'll take up the questions. Yeah. Look at this. The curve drawn between the velocity and frequency of the photon in vacuum. In vacuum, this photon is going to be associated with electromagnetic wave, where the speed is given by the formula E naught by B naught. This clearly tells it does not depend on frequency. Not depend on frequency, isn't it? It does not depend on frequency. So if I plot the graph between the speed of the electromagnetic wave and the frequency, it is going to be a straight line. It is going to be a straight line which is parallel to the which is going to change. Frequency is changing, right? Yeah, frequency is changing. So frequency keeps on changing, but the speed has to remain same. So the speed will remain same for this frequency. Even if you change the frequency, the speed will remain same. Even if you change the frequency, the speed will remain same. Since the speed does not depend on the frequency, for irrespective changes in the frequency, for different values of the frequency, the speed of the light is always going to be the remain same. There will be no change at all. So if I want to write the frequency for the metal A, this is done. For metal B, for metal C. For different metals, maybe the value will change in the frequency, but the speed of light will not change. When speed of light is not going to change, when it does not depend on the frequency, it must be parallel to the velocity axis. It must be parallel to the velocity axis. Look at this. RMS value of the electric field from the sun is this. Electric field is given. RMS value. What is the average total energy density? What is the average total energy density for the electric field? It is half times of epsilon naught into E squared, right? Half times of epsilon naught into E squared. Half times of epsilon naught into E squared. Can you do the calculation for me? Half times of epsilon naught value is 8.854 into 10 raised to minus 12. What about E squared? 720 squared. 720 squared. Can you do the calculation part for this? So 8.854 divided by 2. That is 4.427. into 720 squared, right? 720 into 720. It is going to be something like it is almost equal to 2294,956 into 10 raised to minus 12. This can also be taken as 1, 2, 3, 4, 5, 6. Approximately 2 point something, that is 2.2 into 10 power minus 12. 2.2 into 10 power minus 12. So it is average energy density, energy per unit volume. So joule per meter cube. So this is the energy density because of the electric field. Now you have to find the total energy density. You know the formula for the C, which is nothing but E by E naught by B naught. Now E naught is nothing but C times of B naught. Or also you can say B naught is equal to E naught divided by C. So you can find what is the magnetic energy also by using the formula of times of B naught squared divided by mu naught. Mu naught. Clear? Yeah. So UB is equal to, you know that B squared. B squared is nothing but E naught squared by C squared. So 720 squared divided by C squared, that is 3 squared into 10 power 16 into this 2 as it is. You know that mu naught value is 4 pi divided by mu naught is 4 pi into 10 power minus 7. Mu naught by 4 pi is 10 power minus 7. So mu naught value is 4 pi into 10 power minus 7. So this energy, if you calculate, it is going to be found to be approximately, you can tell, it is going to be 2.3. It is also closely to magnetic energy is 2.3 into 10 raised to minus 12. Therefore, what is the total energy? Total energy will be this, add up. Sorry, it is minus 6. Because I shifted digits, no? 6 digits I shifted here. So if I added up these two values, it is found to be 4.5 something into 10 power minus 6. So you can take up the option A as the answer. Yeah. Look at the third question. Electromagnetic wave, it is going through this electric field, that is E is equal to E naught sine kx minus omega t. What is this k by omega? K by omega is the speed of light, c. So it is independent of wavelength, c, because k is given by the formula 2 pi by lambda. Omega is given by the formula 2 pi f. But f depends on wavelength. You know that frequency and wavelength are inversely proportional. K omega also depends on frequency and wavelength. So the only independent of wavelength is k by omega. Because k by omega represents a c, where c represents the speed of light. Velocity of the electromagnetic waves in a medium depends upon what? Velocity of the electric wave, electromagnetic wave is given by V is equal to E divided by B. V is equal to E divided by B, where it depends on electric and magnetic field of the medium. So velocity of the electromagnetic wave depends on electric and magnetic properties of the medium. That is, option C is the right answer. There is a parallel plate capacitor is charged, that is 60 microcoulomb. Due to the radioactive source, the plate loses the charge at 1.8 into 10 power minus 8 coulomb per second. This is Q by T. You know that Q by T is nothing but the current. What is the magnitude of the displacement current? What is the magnitude of the displacement current? What's the definition of the displacement current? Displacement current is the current. It is due to the loss of the energy. So displacement current is nothing but the basic is Q by T only. Q by T is already given. That is 1.8 into 10 power minus 8 coulomb per second. So option A is the right answer. 1.8 into 10 raised to minus 8 coulomb per second. So whatever the charge is going to lose, that charge loss is going to create what? Electric field. So it creates the change in electric field. So whatever the change in electric field is there, that change in the electric field is going to constitute because of the displacement current, that is Q by T, which is given as 1.8 into 10 power minus 8 coulomb per second. You know that the clouds are going to be contained in the atmosphere by troposphere, which is in the atmosphere. That basic question they have given. So this is once again we got the same question. E is equal to E naught sin kx minus omega t. The quantity which is independent of wavelength is k by omega. Now, in the plane of the electromagnetic wave propagating in the space, electric field amplitude is given E naught. Now they are asking you to find the amplitude of the magnetic field, that is B naught. Whenever the electromagnetic wave is moving, what is the speed of light in the electromagnetic wave? The speed of the electromagnetic wave is given by the formula C is equal to E naught divided by the B naught. C is equal to E naught divided by the B naught. So from this equation, what is the magnetic field at the peak value means B naught is equal to E naught divided by C. So what is E naught? 9 into 10 power 3. Whole thing divided by speed, that is 3 into 10 power 8. What is 9 divided by 3? 9 divided by 3 is 3 into 10 power. When 8 goes to numerator, it becomes minus 8. 3 minus 8 will be minus 5. So what is the magnetic field B naught? 3 into 10 power minus 5. So option D is the right answer. Clear? So this is not there in the NCERT, they have removed it. Now let us take up this. According to the Maxwell's hypothesis, the changing electric field gives rise to what? Magnetic field. Even this ozone layer and radiation of average output, and even dE by dt is also not required. Yeah. Electromagnetic theory was like failed to explain which phenomena. You know that this electromagnetic wave is going to be explained based on which theory? Wave theory. So electromagnetic theory is going to be basically a wave theory. When electromagnetic wave is basically a wave theory means the wave phenomena can be explained. You know that the wave phenomenon are like interference, diffraction, and polarization. Interference, diffraction, and polarization. So these are the three important phenomena in the case of electromagnetic waves. But this electromagnetic wave theory fails to explain the photoelectric effect concept, because you know that photoelectric effect is going to be a particle nature. Since it is a particle nature, it cannot explain the concept of the photoelectric effect. Then this is not required. This is also not required. Look at this. The average value of electrical energy density in the electromagnetic wave. Only they are asking you to find the electric field energy density. So you know that energy total is due to electric field plus magnetic field. Now they are expecting only for electric field, this one. What's the formula? Half times of epsilon naught into E squared. Half times of epsilon naught into E squared is the expression for the electric field. If it is peak value, you have to write. Then what about the magnetic field? What about the magnetic field? Half times of B squared divided by mu naught. But there is both electric and magnetic field. But in the options they're talking about in terms of electric field, so I'm going to use the concept of times of epsilon naught E squared and of times of B squared by mu naught. Now, what will be the total energy? Can I take out of epsilon naught E squared plus of times of B squared divided by mu naught. This is the total energy of the electromagnetic wave. Now, they are expecting the average. Since it is going to be divided by the two parts, one is for electric field and another one is for magnetic field. This is the electric field for the electric field, energy for the electric field. If you want to find the average energy will be half times of electric field. Reason, the other half is going to take up by the magnetic field. So clearly you can tell half of the electromagnetic energy, so half times of epsilon naught into E squared, which is going to be 1 by 4 times of E squared. So average energy will be U bar. U bar is the average energy that is found to be 1 by 4 times of epsilon naught into E naught squared. This is the total electric field energy density that is half times of epsilon naught into E naught squared. So anyway, X-ray is not there. So mesosphere is also not going to be required, and the coefficient of absorption. Then the wavelength of the infrared rays is of the order. Infrared means what? Radio waves, microwaves, infrared. So it lies in between, like infrared means it should be diverge more. They have not given the order. We can tell it is going to diverge more because still it has more wavelength, because still we have visible, UV, X-ray and gamma ray. So below that infrared still we have 4 rays. So it will deviate more itself. So it can't be in the order 10 power minus 3 or 5 into 10 power minus 7. So it will be in the order of more only. So we can say it is going to diverge more. Look up this. The speed of the electromagnetic wave in vacuum depends on the source radiation. Then what happens? Look at this. You know that the speed of the electromagnetic wave is given by the formula C is equal to E naught divided by B naught. It doesn't depend on any source. Not depend on any source. Therefore, for all the sources, the speed of the electromagnetic wave in the vacuum must be same. So C is equal to E naught divided by B naught. Now, you consider the following 2 statements related to linearly polarized. You know the meaning of polarized one, right? Polarized one means the vibrations of the particles are going to be in the same phase. Vibration of the particles are going to be in the same phase. If it is all the vibrations are going to vibrate in the same phase in a single confined plane. In a single confined plane, if all the particles are going to vibrate, then it is called a polarized light. Now we have to discuss that polarized light with respect to electromagnetic waves. Electric and magnetic field have equal average values? Yes, it is true, because electromagnetic wave is going to create because of the contribution of both electric and magnetic fields. So electric field and magnetic field will have the equal average values. It will be having the equal average values. Look at the second one. Electric energy and magnetic energy have equal values? Yes, this is also true, because this electric energy and magnetic energy are associated with what? Electric field and magnetic field. So this electric energy and magnetic energy are associated with electric and magnetic field. Therefore, both the statements are going to be the true. Both the statement are going to be the true statement. Yeah. So the amplitude means the maximum one. Amplitude means the maximum one. The maximum of the magnetic field of the part of the electromagnetic wave in vacuum is this. What is the amplitude of the electric field? It's quite simple. You know that C is equal to E naught divided by B naught. They're expecting you to find the electric field E naught. E naught is given by the formula C into B naught. What is C? 3 into 10 power 8. What about B naught? 510 nano. 3 into 510 means how much? 1530. Into 10 power 8 minus 9. Nano means 10 power minus 9. So 8 minus 9 is nothing but minus 1. So this clearly tells it is equal to 153 Newton per coulomb. So which is the right option? Option B is the right answer. 153 Newton per coulomb. Look at this question. Radio wave is going to diffract around the building through the light waves do not. Radio wave can diffract, but the light wave cannot get diffracted. What may be the reason for this case they are expecting? You know that the radio waves is having much larger wavelength compared to the light, because after radio you are going to get micro, after micro infrared, after infrared you are going to get visible. So infrared is having much larger wavelength compared to the visible. Since it is having more wavelength, it is going to get diffract more. So option B will be the right answer. Yeah. Look at the 13th one. Which of the following relations is correct? Which of the following relation is correct? You know that C is equal to 1 divided by root epsilon naught into mu naught. Correct, no? So speed of light C is equal to 1 divided by root epsilon naught into mu naught. Also, C is equal to E naught divided by B naught. C is equal to E naught divided by B naught. So you can do the cross multiplication, right? E naught is equal to C times of B naught. What is C? 1 divided by root epsilon naught into mu naught into B naught. So C is nothing but 1 divided by root epsilon naught into mu naught. Do the cross multiplication. B naught is equal to root of epsilon naught into mu naught into E naught. So B naught is equal to root of epsilon naught into mu naught into E naught. So which is there in the option B. So option B is the right answer among the relation between E naught, B naught and epsilon naught and mu naught. Clear? Yeah. Coming to this. C mu naught represents permittivity, permeability. Epsilon and mu r represents permittivity and permeability. What is the refractive index of the medium? How do you define the refractive index? Refractive index is defined as the speed of light C by V. What is C? 1 by root epsilon naught into mu naught. V is 1 divided by root epsilon into mu. This can also be taken as root of. This denominator of a denominator goes to numerator, that is epsilon into mu divided by epsilon naught into mu naught. So the refractive index is given by the formula n is equal to root of epsilon mu divided by epsilon naught into mu naught. So you can take up the option B, which is the right answer. So option B will be the right option. Clear, students? Yeah, still some of the questions are there. I will discuss those questions by segregating up in the next session. So we have the questions based on electromagnetic waves still. Based on that electromagnetic waves, after that we can analyze the electromagnetic spectrum questions. So that completes electromagnetic waves. So in the next session, I can complete this chapter. After that, I will continue up with the first PU portions. Is it fine? Okay, thank you. I'll continue in the next class.